Good afternoon again, guys, and thank you so much for making time to join this session. This is another knowledge sharing session. We normally have knowledge sharing sessions every 2 weeks on Saturdays afternoon, and we have different engineers coming in to present different topics in network engineering just so that they can share their knowledge with the rest of the team. We've covered a few sessions already. This should be our 8th or ninth session. And we encourage anyone, if you have a topic that you feel you can share with the rest of the team, it could be IP routing, it could be wireless, it could be DWDM, any network engineering topic that you feel you can share with the rest of the team. You're also welcome to be part of this initiative where we try to share the little knowledge that we have, empower the rest of the engineers, especially those who are starting in their career as network engineers, and give back to the community. So again, thank you so much for always making time to join these sessions and actively participating. We appreciate your presence. And today we have a session on OSPF. This was in our second session, actually, we did cover some basics of OSPF. It was covered by Martin Motiva, and today they are collaborating with David Muita, to give us an advanced lab of OSPF features. So before I welcome them to start the session, just ensure that your mics are muted to avoid any kind of disruptions when we are going through the discussions. If you have any question, always raise up your hand, or you can wait until there is the Q&A time. At the end of the session, we normally have Q&A, but also during the session, they will be giving you time to ask your questions. So use that opportunity to ask questions so that we also avoid disruptions when they are already in the middle of explaining some key concepts of their presentation. So let's keep the mics muted. You can also ensure that your cameras are off. And I hope we will have an interactive session. We all participate actively by asking questions, by responding to their questions if they have any questions for the audience, so that we make it as interactive as possible. So thank you so much again for joining. And I hand it to David and Martin Modiva to take us through the session.
Good afternoon, everyone. I hope you all are well. So, for those who don't know me, my name is Martin Mudiva, and I'm a fellow network engineer. And today, I'm going to show you guys the advanced side of OSPF, alongside with David as well. So, allow me to share my screen to walk you through the topology. Can you please confirm if you can see my screen? Okay, great. So here will be the head office. So the head office will be the campus fabric network. And then here will be the MPLS breakout, and this will be the internet breakout. Then over here will be the MPLS, that's David's territory. And then on the left here will be the regional office. So the regional office also has a black backhaul router that connects to the wireless provider to bring in the kiosk sites via DMVPN. So before I start, are there any questions about this topology?
Yes, from my side, I would request if you can zoom so that at least we can see clearly all the components of each segment, at least before we start doing the configurations, to make it more clear to the rest of us.
Okay, no problem. All right, I'm gonna hand over to David to also explain his segment. David,
Okay.
off to you.
Yeah. Thanks, Martin. Good afternoon, everyone. For those ones of who are joining for the first time, welcome. My name is David. I'm a network engineer, and we've been doing these sessions together with Martin. I think we had Eve. We had BGP. My sessions were the last 2 weeks, they were following each other about MPLS. And today we're happy to come back to you guys and sort of try and depict a real world scenario where, as Martin has clearly mentioned, if you can see from your screen, he will be concentrating on the regional office and the campus head office, while my responsibility will be purely in the service provider environment, the one that is indicated down there, MPLS provider, BGP AS number 32,000. Specifically, I will only be, so MPLS is pre-configured within that environment. So the only thing that I will be doing is just to show you the configurations in that Johannesburg PE on your left, and the Cape Town PE on your right. And I remember, I think it was Sefo who wanted to, see how we can use OSPF as PE to CE peering. And today we are happy to demonstrate that, where we will be doing OSPF as PE to CE peering, both at Johannesburg and Cape Town PEs. And we would be able to show you sort of the challenges that you can actually face or expect when you're doing OSPF as the PE to CE peering, and why we would maybe recommend to use BGP. But not let me not get ahead of myself. I think I would allow Martin to proceed, because my segment is very short, about 5 or 10 minutes or less. Then we can have to we can get to have the discussion on OSPF. So over to you, Martin. I hope my segment explanation was clear. If anyone has a question, maybe we can ask after, during the Q&A. But if it's a burning one, then you can feel free to ask.
Okay, cool. Thanks, David. Confirming, so you guys can still see my screen, right?
Yes, it's visible.
Okay. Okay, brilliant. Okay, so this will be the agenda. So I'm going to start with the OSPF conditional and unconditional redistribution. So before I go into the nitty-gritty stuff, what is redistribution? So redistribution is when you want to inject routes coming from another routing protocol into another routing protocol. So in this case, in this topology, I've got BGP running in from the MPLS CEs to the data center. Reason being BGP, it's because I have VXLAN configured, and I've got the EVPN as well. And then on the WAN side, I have OSPF, but this is meant for demonstration. I wouldn't. We just want to show you why is it not recommended to run OSPF on the WAN side. But again, yeah, this will be for demonstration. So I'm going to start with the conditional side. So the conditional is if I want to add routes, let's say from BGP into OSPF, um, there will be a policy, and if that policy meets the requirements, then that route can be injected into OSPF from BGP. So the conditions can be tagging and untagging. The other conditions can be prefixless, accessless, and route types. So I'm going to start with with the tagging and untagging. So I'm going to go to my terminal, confirming you guys can see my terminal. All right. So I'm going to go to the MPLS router. And in the MPLS router, I am logging in using TagX. So the IC component is involved. So I'm just going to show you the current OSPF configurations. So as you can see, it's quite minimal. So at the moment, the service provider is only receiving a default route. So meaning that the service provider is not receiving any specific routes. So to confirm that, I'll type in show IP OSPF database self-originate. So self-originate is I need to see what am I advertising to David. So as you can see, I am only advertising a default route and it's coming from LSA type 5. I'm also advertising the directly connected interfaces. There we go. So I'm going to configure a new policy. So it'll be a route map, and that route map I'll name it as BGP to OSPF. If I don't add a permit by default, the permit value will be 10. But in this case, I'll just add one. I'll say any routes that are coming from OSPF, give them a tag of 6,000. And because it's a primary, I can either set the metric or I can set the metric type. So if I set the metric, what that means is uh, the lower the metric, the better. And then with the metric type, there's type 1 and there's type 2. So type 1 will always be preferred because it will reveal the real cost to the destination. And then type 2 will not reveal the real cost to the destination regardless of hop count. So with the metric type, use it with special caution. But just know that when you configure the metric type 1, your metric will increment per hop, meaning that when you do it in a topology that doesn't require that, you may cause routing loops. So in my case, I'm only advertising to the provider. So I will stick to metric type 2 and control the routes using a metric. Okay. So I'll then say set metric. I'll say 1. And then in reverse, I'll say OSPF to BGP, and I'll put in deny 1. So the deny 1, I want to match the metric, the tag 6,000. What this means is, as I bring in routes coming from BGP into OSPF, I'm tagging them with 6,000. But in return, I do not want a copy of the routes that I already have, because if I do that, I'm going to introduce a loop into the network. And then to avoid an implicit deny, I'll add a permit 1000. Reason why I add a permit 1000, I'm giving myself room to add any other denies as required without having to remove the implicit permit every time. All right, so I'll now verify the policy, which is OSPF to BGP. So we can see that it is BGP to OSPF. My apologies. Just give myself more room here. There we go. So from BGP to OSPF, so basically I'm taking routes that are coming from head office, and I am injecting them into OSPF for David to learn them. And I'm going to give them a tag of 6,000. And confirming the reverse, BGP routes, I want to strip off tag 6,000 and I want to allow the rest. So let's do it. So we OSPF 100 redistribute BGP 65002. I will call out the route map. So what is my route map? My route map is BGP to OSPF. So before I proceed, I will type in show IP OSPF database self-originate. And there you can see, I can see the routes that are coming from BGP and they are tagged with 6,000. So now to confirm that these routes are coming from BGP, I'll type in show IP route 10.10.1.0, and we can see that this route is known via BGP AS 65002. So now in return, I will go to 65002 and then I'll go to the address family IPv4 unicast redistribute OSPF 100. I'll call out the route map. So my route map in reverse, it'll be OSPF routes to BGP. And then I need to verify that the data center knows how to get to the regional office. So I'll type in show IP BGP. As you can see, the routes that are redistributed, as you can see, they are given a weight of 32,768. So that's by default. So if you take a an IGP and you want to inject those routes into BGP, by default, BGP will always give it a weight of 32,000. So I will go back to to yes, is there a question? Okay, no question. So I will go to my first fabric edge switch. And from my fabric switch, I have OSPF running here, but I am not using OSPF to get to regional office because OSPF in the campus fabric is an underlay. So I'll go to show IP BGP, VPN v4, VRF, campus fabric. And I can see that I am learning the regional office routes right here. And if I call out one of the routes, I can see that this is coming from the border from the border edge switch in the fabric, and I can see that it is marked with the L3 EVP and VNI tag. So that confirms reachability. All right. So before I continue with the next method, is there any questions regarding tagging and untagging?
Yes, maybe someone will ask, why are you tagging the routes? Maybe from the initial explanation, maybe if you can just repeat so that we can get it clear. Why do you have to tag the routes? What is the
Okay.
use of the route tagging?
So route tagging can be for loop prevention. It can be for honoring other routing requirements. Like for example, if let's say I want to take a route that's coming from OSPF on the WAN, and I want to bring it into BGP. Say for example, I have um, another router here, and that router is expecting specific routes. So with tagging, I can tell that router, hey, you know what? Only allow routes that are coming from the specific tag. So when you use that method, you avoid stuff like you avoid having a very long prefix list or an access list that's going to end up becoming a nightmare to manage. I hope that answers the question.
Yes, yes, it's clear. Thank you.
Okay, cool. All right. And before I proceed, David, you may share your screen and then you can confirm what routes you're getting from me.
Okay. You can stop sharing now. Let me need to share my screen. Entire screen. Hold on. What screen are you seeing, guys? Let me know, please.
Yes, we're able to see Mobox term.
Okay, thank you. So I am supposed to log into the Cape Town PE. Oh, that's Johannesburg, and then the one on your left. If you remember the topology that Martin shared, Cape Town is on your left. Then sorry, Johannesburg is on your left. Cape Town is on your right. So the regional office is on your left, and then Martin, confirm that the what is it called? Data center is on your right, right?
Yeah, that's correct. Yes.
Okay, so I'm in Cape Town, so I'm supposed to confirm. First of all, in here we are, as you can see, we are running the customer VRF. That's the customer VRF, the customer one as the name, and we've done the route import. Some of these stuffs we discussed during my MPLS 2 sessions. So if I want to confirm what routes I am getting from the data center, the command will be show IP. So we are doing OSPF as the P to C peering. So the command will be show IP route for VRF customer one, and in here you can see I'm getting a whole lot of OSPF routes. I can actually filter this and say OSPF. So we are getting OSPF routes from this particular guy here, 10.1, and then we have 10.3. This one would these are the CEs that are in the data center. So we are getting a default route like Martin had shared. He's advertising a default route to me. So I'm getting it as OSPF. I'm getting it as OSPF external type 1. And then these other ones here that we can see, I'm getting them as external type 2. So these are the routes that I'm getting from Martin seated at the data center. So that is for Cape Town. In Johannesburg, that would be the PE to C peering that we've done with the regional office. Again, we can show run VRF just to confirm that everything here is fine. That is our VRF. That is our route distinguisher. We talked about this and what it does, and that is, or those are the route targets for importing and exporting. And in terms of maybe show run section or SPF, just to show you the PE to CE peering, those are the commands. So the OSPF process has to be for the customer VRF. As you can see, we have the customer peering here in this section, and this other OSPF here is for the internal MPLS. So we're not going to touch about this. This is to enable reachability within my MPLS backbone. But for the pairing with the CE, those are the commands, and we can actually verify that and say show IP OSPF neighbors. And as you can see, there is where we are having the PE to C customer. So in the regional office and the data center, we have two CEs pairing with me in Johannesburg and Cape Town, but using one PE. And the reason as to why I know that is the peering is because we are using the sub interfaces here to depict that particular PE to C peering. We can actually go into this particular interface here and show run that interface. Sorry, I pasted 2 times. And you can see this interface is assigned to our customer VRF. The same thing applies to the other one. It's under the customer VRF. So I can confirm that OSPF neighborship is up. So let's go and confirm if we are getting any routes from our regional office. And the command is, so those will be OSPF routes. So the command is show IP route for VRF customer 1. I just need OSPF routes. And you can see we are getting the inter-area routes from our regional office CE, which happens to be .5. I think that would be this guy here. So these are the OSPF routes that we are getting. And Martin, I think I should also show that these routes that we are getting from the regional office in Johannesburg, because we've done PE to CE peering and then we've done mutual redistribution, we are also able to get these particular routes in Cape Town. So if I remove the OSPF keyword, as you can see, let me just pick one route here. For example, this one, and then say show IP route VRF customer 1, that particular route. And as you can see, we're actually running it via BGP because, as I mentioned, in Johannesburg and also Cape Town, if you, I quickly take you to that configuration. We have done this command here. So this, we talked about this this kind of configurations in our last session. Now, instead of doing BGP as PE to CE peering, what we are doing here, we're just now doing OSPF as PE to CE peering. And down here, this is where we are doing that distribution. So because external routes are not imported or redistributed by default in when you're doing BGP to OSPF redistribution. So this command here is important for you to actually be able to redistribute your external type 1 and external type 2 routes. If we remove this, for example, just for demonstration purposes, and say, let's go to conft. Let's go to conft, a global configuration mode, and our router BGP 32000, and then we go to our address family IPv4 for VRF customer, and then we remove. First of all, let's confirm what we are getting in. We've confirmed in Cape Town, we are getting all these routes coming in. Okay, so watch and see what will happen if I remove this particular command and say no. So if you go back to Cape Town and issue that command again, show IP out VRF customer. Now, I think we should be able, we're not supposed to get
David. So on that step, what I'll do, I will log into the regional office, and I'm going to influence all of those routes to be external, because right now they are internal.
Yeah.
But yeah, so my my interaction between myself and David, it's like I'm the customer, David is the service provider, and we're interacting and we're trying to bring a service up. David, I saw there was a question relating to why we adding the capability VRF Lite.
Okay. That would be under the OSPF process for our VRF customer. Let me just go back there. I can just pipe it. Okay, so let me go and re-add this command, and then we can discuss about it later maybe. Always remember to save your configurations. So show run section OSPF. That command is here. And as you can see, it's under the OSPF process for VRF customer one, which we're using to peer between our Johannesburg PE to the regional office. So capability VRF Lite, basically it's how can I put it? Let me just see if I can get the correct terms to describe it. So what this so when you're using OSPF as the PE to CE peering, there are routes that are rejected by default because, just to prevent loops. So this particular command here allows those routes to be injected into your now I'm in my PE. So those routes, that command allows the routes to be injected into your OSPF customer one process, for example, and then therefore after you have those routes injected, then you can be able to advertise them to the other PE. So this only happens when you're doing OSPF as the PE to C peering in MPLS L3 VPN. I think that would be the explanation. Basically, the main point is, or the main story we're having that command is to avoid loops between BGP and OSPF when you're doing mutual redistribution. So without that command, there are routes you can you will not receive. So maybe Martin, we can demonstrate that.
Before we do that, David, let me finish all of the
Okay.
methods of the redistribution button. But thanks for the demonstration.
All right. Thanks.
Martin, your hand is up.
Yes, I was expecting to see the tags also on the David side. Are the tags being propagated to David?
Oh, David, yes, you may check this. So sorry, Martin.
So I need to share again. You can see my screen. Are you still seeing Mobax terminal, guys?
Yes, we can see your screen.
Okay, so Martin had configured tagging. So I should be able to check that. There's a command that I had run before. I don't know if it was here or here.
Yeah, if you show the specific prefix, I believe that's where we should be able to see the tagging.
Okay.
Yeah, there's the tag. I
So
see it.
I need to highlight this for the guys to see. So I'm getting those tags that Martin had and had shared, and as you can see, the type 5 external LSAs.
So
Yeah, that's it.
the tag will only be on these OSPF LSA, but not on the exact IP route.
So you want me to go to inside a specific a specific prefix, for example, to show if you can get the tags.
Yes, in the route in the forwarding table, does it also have the tag, or it's just the, I don't know whether.
Martin?
Yes, if you type in, yeah, that VRF and you can pick one of the prefixes coming from the data center. Yes, the root tag right at the bottom.
Yes,
There
yes.
you
Okay,
go.
yeah, that's actually what I wanted to
Yeah.
see.
Okay.
Okay, thank you.
All right, Martin, you can take it. You can take the screen back.
Okay. The question of why we applying the BGP default information originate. We will come back to that if you don't mind. Okay, so I'm gonna share my screen again. So now what we did was tagging and untagging. So now I am going to use prefix list. So I take it that you guys can see my screen. Okay, so I will go back to my MPLS CE, log in with my TACX user, and I'll go back to OSPF 100. I'll say no redistribute BGP 65001. Oh, okay. So if I type in show IP route BGP, so now say for example, I am interested in routes that are only starting with um, 10.10.0.0 slash 20 as an example. So now this is prefix list. So now in prefix list, you must be careful how you classify your prefixes. So if I go to IP prefix list and I'll put in BGP to OSPF filter, I'll say sequence 1 permit. So it will be 10.10.0.0. So if I go back to my marker here, so I'll put in x.x. 1, 2, 3, 4, 5, 6, 7, 8.x. So I'm looking for slash 20. So it'll be 16, 17, 18, 19, 20. So my line is here. So meaning that it will be 128, 192, 224, 240. All right. So now to get the wildcard mask, basically it will be 255 minus 240. So I'll open my calculator. So that'll be 255 minus 240, and that will be my wildcard mask. So if I go back to my prefix, so that will be slash 20, and I'll say, hey, only go up to slash 24. Do not add these ones here, and don't add the rest. So if I type in show IP prefix list, so I have this prefix here, and then I'll add another route map and I'll configure BGP to OSPF filter, and I'll put in permit 1, and I will configure match IP address. So be careful on this one. So if you don't specify prefix, it will look for an access list. So be careful because you can end up black holing routes. So I'll call out the prefix list. I'll copy I'll copy it and paste it in. I won't add a tag, and I'll go to router OSPF 100 redistribute BGP 65002 route map. I will call out that route map. I'll press enter. And I'll type in show IP prefix list detail. And I see 3 hits. So now let's see what is advertised. So I'll type in show IP OSPF database self originate. And as you can see, we only added 3 prefixes as expected. But this time, notice that it rather took the tag coming from the BGP ASN that's coming from the head office campus fabric. And to confirm that, I'll type in show IP BGP 10.10.1.0. And as you can see, it's coming from this ASN. And also to confirm show IP BGP. So you can see that it is coming from this ASN. So the routes that I'm self-originating, that means that David will only receive these routes. That's it. So when you use prefix lists, use them with special caution. All right. So before I proceed, is there any questions regarding using prefix lists? Okay, no question. So I'll go to router. Actually, I will now add an access list. And that will be standard, meaning I'm only focusing on the source. So that will be BGP to OSPF filter. And in here, I'll say permit 10.10.0.0. So if I go back to the calculator, notice that I've made this calculation here to 15. So meaning that the wildcard mask will be 0.0. So the 0.0 meaning that I don't match this value, match that value, and then 15 will be here, and then 255. So meaning that he says match him, and him, but have a limit of subnets that are applicable with the subnet 240. Okay. So I type in show IP OSPF, sorry, IP access list, BGP to OSPF filter. Notice that I have added the wildcard mask in there. So the differences between the access list and prefix list, a prefix list, if you add it as a /20, the prefix list will look for a subnet that is /20. So if it's not in the routing table, it will not match it. But up until I add the LE or length, and I specify how far the prefix list can go when it comes to the match criteria, that's where it can match based on that limit. So understand that condition. All right, so I'll go to route map BGP to OSPF permit, actually filter, sorry, filter. Permit 1, I'll say no IP address. No match IP address prefix list BGP to OSPF filter. I will repeat the command, but this time with an access list. So I'll put in match IP address, but this time I'm not putting in prefix list. I'm telling the route map this time, look for an access list. Don't look for a prefix list. And to verify, if I go to the route map, that'll be BGP to OSPF filter. And as you can see, it's now looking for an access list. So I will go to my OSPF process. I will put in redistribute BGP 65002 route map. And I'll call out this route map here, then that's matching the access list. I'll press enter. So I'll go to show IP access list and I'll put him in there, and we can see, and there we can see matches right there. And if I put in show IP OSPF database self-originate, this is the routes that we can see. So this is the differences between a prefix list and an access list. So before I proceed, are there any questions? No questions? Okay, I shall proceed. So then the other method is root types. So with the root type, I only have external. But what I can do is if I type in show IP OSPF database self originate, and if I go to this guy, so let me do this quickly. So I will get rid of this redistribute connected and inject this root map with and inject it under the LSA type 1. So I'll go to router OSPF 100 and I'll apply no redistribute connected. And I'll go to the root map IP OSPF 100 area. Is it area 1? Let me just check. OSPF interface brief. It's area 1. Okay, there we go. And it'll be IP OSPF 100 area 1. And to confirm that, show IP OSPF database self originate. And I should see that under the LSA type 1. So now what I'm going to do is I'm going to go back to my root map, and it will then be BGP to OSPF filter. So I am not going to touch this root map now. I'm going to create another one. I'll name it as OSPF root type filter. I won't add in the permit. So if I go to show root map and I copy him in there, notice that he has permit 20 like what I mentioned earlier. So now what I want to do, I want David to only receive an internal root from me and also receive a default root from the external. So how to do that, I'll type in match root type, and that will be internal. So meaning that the root type internal, it will look for roots that are coming from LSA type 1 and LSA type 3. It will not look for roots that are coming from LSA type 5 or LSA type 7 if these are not so stubby. So I'll go back to my OSPF and I'll put in redistribute. I'll say redistribute connected root map. I will call out my root map, this one here, there we go. You know what, let me do it. Let me do it this way. I'll say IP OSPF 100 area 0. Show IP OSPF database self-originate. And I should not see the loopback IP under LSA type 5. I should see the loopback under LSA type 3 because I put it under area 0, but my peer with David is OSPF area 0. And as you can see in the self origination here, any questions? No questions? Okay. All right. So then I will then go to my existing route map, BGP to OSPF filter, and I'm going to remove this access list, and I'll tell it to only match the root type external. So I'll go into the root map, BGP to OSPF filter, permit 1, no match IP address, and I will negate this fellow here. And I'll rather say match root type external contextual help. So in here, you can be ultra specific. Do you want to match type 1 or type 2? So let me start with type 1. So yeah, will be type 1. And then because I do not have OSPF routes coming from BGP, I'll just make use of that to redistribute directly connected interfaces. So I'll go to OSPF and I will say redistribute connected, and that will be route map. I will add, where is that route map? Yeah, there you are. Come here. Okay, you giving me issues. Okay, it's fine. I will rather do this when I come to this section here, because I'm going to configure not so stubby. So then that command doesn't match my condition, but that's okay. That's another limitation. All right. Now I'm going to hop into the PRC, or the partial routing calculation. But before I proceed, is everyone okay with these methods? Are there any questions?
Yes, maybe which one will you recommend? Which one is the best option to go with, or it depends with the scenario that you're trying to achieve?
It depends with the scenario. But to give you a generic answer, I would keep it as simple as possible. When you configure these networks, you don't configure it in such a way that it's not troubleshooting friendly. Simplify it so that when it breaks, that they don't always depend on you. Remember, you also have a life as well. So rather simplify it so that other engineers can also troubleshoot what you configured. So in my mind, I'll say if it's a metric type 2, I'll always recommend that, because you have control of the route. The metric doesn't increment. So regardless of the hop count, the metric that you set, if you're using metric type 2, will not increment dynamically. It will only increment from your command. But if it's metric type 1, and if I go back to the topology, sorry. So if it's metric type 1, assuming that we're not running BGP here, we are running OSPF all the way. What that means is, if I am advertising routes coming from the segment to the switch all the way to the MPLS, and I tag him as metric type 1, so that means that when he goes to the switch, the metric will increment. When it lands here, the metric will increment. Now that's going to be a problem, because your your network design does not, or this network design does not I wouldn't recommend that in this type of a design. For metric type 1, metric type 2 scenario, I would rather recommend it if you have a core switch or core switches, or if let's say you have a stack and you're running OSPF with the CEs, and you do not have any OSPF segments in the back end, then the metric type 1 will be a perfect fit. And also supporting that on the CE's backend to the PE, you're running BGP. If it's OSPF, don't do it, because with OSPF, with the command that David applied with the capability VRF light, that is stripping off the DN bit check. If you do that, you can cause a loop. So do it efficiently. That's what I would say. Martin, I hope that answers your question. I know it was a very long one.
Yes, I believe actually sometimes we need to combine these methods also apart from. Yes, I was speaking in mute. I believe sometimes we also need to combine some of these techniques, maybe one or two techniques, just to be able to achieve the requirements or the scenario that you're trying to achieve. But that was clear. Thank you.
Okay, what is the difference? Let me see. What is the difference between prefix list and distribute list? So a prefix list is a root filter, a root filter classifier. Let me put it that way. And then a distribute list influences the direction of or of where you want the routes to go. Like for example, on this switch here, if I only want to advertise the default route and I want it to go out, and let's say in the back end I'm running maybe EIGRP and I'm running OSPF here. If you configure a distribute list in this guy pointing to him, it's that I only want you to have now I only want you to know about the default route, then that will work. But if it's OSPF all over and you advertise that, you can easily drop your network because it will say, hey, okay, I'll advertise it this path, this path, this path, and this path. Unlike EIGRP, you can configure a distribute list and also tag the interface to avoid that. But with OSPF, you can't do that. Calvin, I hope that answers your question, my man. And then distribute list in BGP, it's the same thing, but um, so applying that command, you know what? I can demonstrate that to you at the end of the session, if that's okay with you. All right. Okay, so OSPF PRC. So what is OSPF PRC? OSPF PRC is a feature by default enabled in OSPF v2 and v3 to help OSPF to not have to recalculate all of the routes within the topology just because one route flapped. What this means is, so if I go back to my router here, let me reinstate everything just so that I can demonstrate it. I'll just configure the redistribution unconditionally. Um, and just want to show you here. So I'll go to OSPF. You know what? No, redistribute BGP 6502, and I'll just reinstate that command. There we go. So if I type in show IP OSPF database, self originates. So I have all of these routes here. So if I type in show IP OSPF and I press enter and I go all the way down, so the PRC starts here. So it starts with the initial. delay, the minimum hold, and the maximum hold. The initial SPF, or the initial shortest path forwarding delay, what this means is, if let's say we have a prefix of 10.10.255.1, and that flaps, so OSPF will say, okay, I will wait for 5,000 milliseconds to start the initiation. And then once I do it, I will wait for another 5,000 milliseconds to ensure that I don't have to do it again. But with these timers, they're too quick. Um, so the only time I would recommend this is if you have a large network and you do not want, and you have routes that are flapping multiple times. And from there, you do not want your OSPF to start hammering your CPU. So if your OSPF domain is large, I would say increase these values, not too high and not too low. If they are too low, it will respond too quickly, and it will hurt your CPU, and it will cause instability. Not too high, because OSPF will end up missing these calculations and also introduce instability. So this is just for the SPF. And then you have the same for the LSAs as well. So how to see that? I'll type in show IP OSPF, and there will be events LSA. So if I go all the way down, so you will see that um, PRC will only concentrate on the ones that are listed as generate or changed, which is these ones here. So and then which LSAs will PRC not focus on? So PRC will not. Okay, I'll come back to your question. PRC will not focus on LSA type 1. No. PRC will focus on LSA type 5. It will focus on LSA type 4. It will focus on LSA type 7. So if it's LSA type 5 and it's listed as change, it will attend to it. So the question is, does using BFD on links have any impact on behavior of these timers? The answer is no. BFD, what BFD will address, let me show you this. BFD will address this. BFD will address the hello and the dead timer. Which is these ones here. So BFD, what it does, it says, okay, OSPF, screw your screw your hello 10 and your dead 40, and abide to my LSA, to my timers. On the other hand, PRC says, I only want to focus on the route that flapped, and I don't want to reset the entire topology. I hope that answers the question. So then how to manipulate these timers. So I'll go to router OSPF 100, and I'll type in LSA timer interval. So if you are using iOS XE, interval will have a dash. If it's normal iOS, then exclude the dash. So I'll put in 5,000. Oops, 5. And I'll say timers throttle LSA. So the minimum weight I'll put in 2,000. Sorry, the initial weight, and then the minimal weight I'll put in 5,000, and the maximum weight I'll put in 5,000. Same applies with the SPF. So how to confirm that? It'll be show IP OSPF. Show IP OSPF. And if I scroll all the way down, and there we can see that the scheduling now has changed to 2000 as configured in the timers bracket, including the LSAs. Um, are there any questions regarding the partial routing and calculation? No questions? Is everyone okay?
Martin, I have a question. Maybe let me ask on behalf of someone. What is the reason as to why we have PRC? If you could
Sorry,
explain.
sorry, repeat your question.
The importance or the use of PRC in OSPF.
The importance of PRC, David, is to ensure that OSPF does not reset the entire topology because of one route that's constantly flapping. So let me give you an example. Say, for example, I have this DB here, and I've got this route that's constantly flapping, maybe because the SVI is flapping or the interface is flapping. So PRC, what it does, it'll say, wait, but I, I will not reset the entire topology. I will only focus on this route that is constantly flapping and I'll recalculate it. David, does that answer the question?
Yeah, it does, Martin. I was asking for a friend.
Ah, okay.
Yeah, it does.
All right. So I will then move forward to the route summarization. The route summarization, my worst nightmare. I actually don't like this topic, but okay. I can explain how what is route summarization. So routes route summarization is meant to shrink routing tables. So say for example, if I go back to the topology, and say, for example, the regional office routers are not really robust routers, or let's say they are robust routers. However, the service provider maybe is complaining that, hey, look, summarize your routes. I don't want small subnets. And then because now in regional office I am bringing in a lot of routes that are coming in, and let's say David says, hey Martin, look man, I've got multiple customers, my PE has too many routes, it's very difficult for me to now differentiate. So now what can we do about that? And that is where OSPF summarization comes in. So if the routes that you want to summarize are coming from a specific area, you will use the area command to summarize. But if the routes are redistributed, it will rather be recommended to stick with the summary. So I will do that first from the data center, and I will say, hey, you know what, I want to summarize I want to summarize this group here. I'll just choose a random subnet mask. So I'll go to OSPF 100, and if it, like I mentioned, if it's an area, it'll be area. Let's say one. Instead of summary, it will be range. And if it's redistributed routes, then it will then be summary. So I'll put in summary. I'll say 10.10.0.0. I'll say 255.255.192.0. In contextual help, I can also tag the summary, which look at that. So if let's say the regional office is expecting a specific tag from the head office in the summary, I can do that as well. I can have the summary, but decide not to advertise it to any peer. or not translated if I have the not so stubby. Or I can say, if I summarize it, I want to only keep it in the not so stubby. So meaning that if I do it this way, I will not translate it to LSA type 5. So I will press enter. And then I also want to summarize these roots as well. So it'll be summarize 10.10.255.0, 255.255.255.0. And let's confirm if it did summarize. And there we go. So here's the summary, and here's another summary. And then notice that it took out the tag. So meaning that I'm the one who is handling the summary, meaning that the root in the router locally, I will have the summary. So IP root. There we go. So I will have these roots as a null zero. What does the null zero mean? The null zero means if I want to reach a specific prefix and it's not in the routing table, I will drop it. I will not allow it to retry because I'll say that prefix doesn't exist. But if it exists and I have it in the routing table as it's coming from BGP, I will send it through. So David, can you please confirm if you're receiving my summary from the Cape Town PE?
Okay, give me a second. Yes, Cape Town.
You can share your screen as well.
Yeah, I think we need to come up with a way of doing double screen sharing.
Yes, yes, yes.
Does someone have a solution in the group? We need to do double screen sharing. Okay. Is it up now?
Yeah, I can see it.
I just need to log in because it had timed out. It's kept on, right?
Yes.
Okay. Just give it a second for it to initiate. All right, there you go. Okay, so my task here is very simple, is to confirm that in my MPLS PE router in Cape Town, I'm receiving the summary routes, right?
Yeah, well.
Show IP route for VRF customer one. That would be OSPF. There you
And there
go.
we go. So you are receiving two summaries. So now
Mm,
so now the question is, and thanks, David.
all
So
right.
now the question that or the scenario that I've seen is if it's in the summary and you type in, and there was scenarios where if you type in show IP root and you show the specific prefix and it says it's not in the routing table, and then it becomes a problem. So how to confirm that? You want to type in show IP ceph and then VRF. You put in the VRF number, and then from there you put in the prefix, uh the cast one there,
Ah,
the
space, sorry.
no, search for 10.10.1.0. So notice that the ceph table says that route that you're looking for will be addressed in that summary.
Yeah.
All right. Okay. And then with the routes that are coming from another area, it'll be the exact same approach, but this time it will be area, and it'll be the area number,
Then
including
range.
then the range. Yes, but be careful when you summarize. My honest opinion: avoid /16s. I've seen /16s being summarized and then they kick you out.
Yeah,
All
that's
right.
from
No,
practical experience.
okay. Yeah, thanks, David. Let me take over. Are there any questions regarding route summarization? Is everyone okay with route summarization? All right. Okay, perfect. So now we will then talk about the LSA suppression. So you'd ask yourself, wait, LSA suppression, what are you talking about? I haven't heard of that before. Well, if you if we discuss it further, the LSA suppression means that you want to suppress the amount of LSAs that the router needs to focus on. So what that means is, if I go to the regional office, 103.255, I think it's dot 3. I didn't configure TechX here. So I should, yeah, there we go. So if I type in show IP OSPF database, so if let's say you want to filter routes, when you filter routes, basically you are telling OSPF, hey, you know what? I want to filter out these routes that are coming from the provider, these 203, 254 routes. What that will do, that will not shrink the LSA table. No, that will tell OSPF, okay, take out those routes out of, or take those routes out of the routing information base, and don't remove them in the topology. So even though you don't have the routes in the routing table, OSPF still needs to maintain the LSAs that are in the LSA table, and that can be resource intensive. Now that is where OSPF stub routing come in. So now what I'm going to do is I am going to go into this router here, the backhaul. So the backhaul 4 5. So the backhaul, that's where I configured the LSA the LSA suppression. So if I type in show run pipe section router OSPF, notice that I've configured LSA, stub routing for area 2. So now with the question is, which LSAs is this suppressing? So if we go to uh, stub, so in stub we are suppressing LSA type 4. We are suppressing LSA type 5, but we're not suppressing LSA type 3. Why? Because this is not configured as totally stub area. No. But if you want the area to be totally stub, what that will do, it will say, okay, you know what? I'll also exclude the specific routes that are that are marked with LSA type 3. So if I go to the IP OSPF, database, notice that we are still receiving a bunch of roots that are in LSA type 3. But now we want to get rid of these roots and only tell the router to maintain default roots only in the routing table and the LSA database. And the question is, where do we do that? So we need to do that in a router or a layer 3 switch that is an area border router. Now the question that you will ask yourself is, what makes up an area border router? An area border router consists of a router that has a backbone area and a non-backbone area. That will be marked as a ABR or a valid ABR. If you have only area 1 in here, you will not be marked as an ABR, meaning that you're not allowed to control the stub routing. It's only the ABR that's allowed to do that. Okay, so I will go to the regional office layer 3 switch. And I'll type in show run pipe section router OSPF. And I will remove this command. I'll say no area 2 stub, but rather I'll say area 2 stub. And to mark it as a total stub area, the keyword is no summary. So the no summary says, okay, you are now a total stub area. So I'll do the same in the redundant switch. The cool part about stub areas is that you can control the routing with the default cost. So I'll demonstrate that now in the secondary, and this will influence who is the best path from the inbound and outbound. So I'll go to router OSPF 100. I'll say no area 2 stub. I'll say area 2 stub, no summary, contextual help. And I will exclude this because it's not necessary. All right, so I'll go to show run pipe section router OSPF. So how I'm controlling the routing, basically I'm saying area 2 default cost. What that will do, it will say I'm only going to focus on stub areas. So if you don't have a stub area and you apply this command, it will not work. So I'm saying this out of, so be cautious when you apply this. So I'm gonna go into OSPF and it will be area 2 default cost contextual help. And as you can see, it says you are only allowed to focus on stub areas. If you know a stub, I will not touch it. All right. Any questions before I verify? Okay. Guys, you are scaring me when you're keeping quiet. I feel like I'm in the closet.
We are still
It's
processing it. We are still processing it.
guys are following. Right? Guys are following.
We follow
so
it
so
closely.
then so then no thanks. So I'll type in show IP root OSPF. Notice that I'm not receiving those roots anymore, but I am receiving a default root, but coming from the primary core switch in the regional office, which is this one here. So now the expectation was, okay, I was expecting it to load balance. And then the other question is, okay, but if it fails, what will tell OSPF that I have a redundant route? So how to find that? It will be show IP OSPF database. And notice that we're not seeing those long routes anymore. We're only seeing a default two default routes, and then the database says, okay, I do have the redundant default route in my database, meaning that if this path fails, then this will kick in. And then if I go to show IP OSPF events LSA, notice that all of those routes that used to come in, they are all marked as change, right? But now on the unchanged, what this will do, this will tell PRC, don't touch the default route. No, don't touch it because the LSA did not flap. That's why it's tagged as unchanged, meaning that wherever I'm getting the default route, it did not flap. So also it will focus on these ones here, receive change. So now the question is, what is this value? So this value will be your database descriptor. So your database descriptor will be responsible of tagging the specific route that is, or identifying the routes that are coming from a specific LSA in the database. So like for example, if I take routes that are coming from this advertising router when we're with this database descriptor, you will see that there are other routes as well that are tagged with the same descriptor. So it will identify the specific route in the LSA with that descriptor. All right. Any questions?
Yes, sometimes they say using this kind of implementation may have some routing issue where you only using the default route and preventing the specifics from being advertised to the other areas. What will be your explanation on that?
So so when it comes to that, so say I configured the not the total stub area and tagging these guys to be in control. What this will do, this will tell this router only accept the default route. But in reverse, the routes that are coming from him, as long as they are not external, and as long as those routes are within the LSA or LSA type 3, they will be exported. So let me show you what I mean. There we go. So I am sitting in head office. So the device that I'm in will be this guy here. And I'm going to trace all the way to this router here. And I'll put in trace 10.103.255.5. So there's a domain lookup in each hop. I do apologize. I forgot to switch that condition off. Okay. There'll be the border edge, and then that will be the primary MPLS CE, and then that will be David.0. and then this will be the IP of David on the other side in the Joburg PE, and then this will be the regional office primary WAN IP. Then this will then be the CE IP, and then this will be the regional office. So depending on your design, so when you configure stub routing, configure them with special caution. So what that means is, if let's say you are in the MPLS, you shouldn't configure stub routing in MPLS. Reason behind that is that you are running BGP, so BGP doesn't believe in the default or in the last gateway of resort when it tries to peer with other prefixes. It will not accept it. It will say, I'm looking for a specific route. So in the MPLS, you want to focus on stuff like prefix suppression to suppress the transit routes. But stub routing, don't apply it in your MPLS core. You will drop a lot of customers, and you will also get an early retirement, which is being fired. So be careful.
Oh, that's clear. Thank you.
All right. Okay, so now let's move over to prefix suppression, my favorite. This can bring chaos and it can bring joy, depending on where you want to use it. So, what is prefix suppression? Prefix suppression is a feature that focuses on transit routes. So, if I go back to the topology, so the transit routes will be the interfaces that are being used to peer within OSPF. So, if let's say I have network statements and I haven't suppressed any hellos, those interfaces will be marked as a transit. However, prefix suppression will not touch loopbacks by default because loopbacks, they have their own unique network type, which is loopback. So now the question is, why would you want to use prefix suppression? Well, I'm going to start with the MPLS. And David, you may correct me here if I'm wrong. So with the prefix suppression, these two PEs, when they talk to one another, they are using loopbacks to peer. They don't they don't really need they don't really need to have the transit routes within the routing table to be able to reach that, as long as the transit routes are in the database but not propagating in the routing table. That's the first scenario. The second scenario is when you are running processes like VXLAN, and you want to build an overlay network, and you want to separate it from the underlay, and still you'll be using loopbacks. And you don't need to have those transit routes within your routing table because you're not using them. So I will demonstrate this in these campus switches. So these campus switches will be the Catalyst 9KVs. They are equivalent to your Catalyst 9300s or your Catalyst 9500s or your Catalyst 9400s. So I'll hop in. So I'll be telnet 10.10.255.1. So so just to confirm, so I have this loopback here that is in the underlay. I also have this loopback here. So this loopback, I'm using it to enable any cast rendezvous points. So what does that mean? It means when I'm running multicast networks with sparse mode, if I mark this guy as a rendezvous point, when he fails, I need to make sure that these guys don't have to recalculate or reconverge in their multicast routing tables or their sessions. So instead, um, I'll have an identical loopback, and I will associate it in the um, in the rendezvous point process, with also in the MSDP. Sorry for stuttering there. Okay, so then I'll type in show IP OSPF interface loopback 0. Actually, interface. I'm looking for where is that specific interface? Let me do this. So I'll say show IP OSPF interface. Type in briefly. I can. You know what? I'll say interface. Actually, oh, you know what? I will not be able to see it. Why? Because I added it in the LSA type 5, which is fine. And that is addressed by this register connected. So I will leave it that way. So then if I type in show IP root OSPF and I type in show IP BGP, not that, it'll be show BGP L2 EVPN summary. So I have all of these loopbacks here. But now if I type in show IP root OSPF, I have these 3 loopbacks. I also have these roots here, which I do not need. So I only want to see these guys in the routing table. I don't want to see the rest. So how to do that? I'll go to router OSPF 100 and apply prefix suppression. So I need to do it in all switches. So it'll be router OSPF prefix suppression. There you go. And I'll go to the third one. And apply the same condition, prefix suppression. I'll save my config and I'll go to the last one. I'll answer that question now. Give me a sec. So I'll go to 100 prefix suppression. There we go. So then I will go back to the first switch where we were seeing the transit routes. And on the contrary, notice that I did not lose access to my switch. So if I type in show IP root OSPF, I only see loopbacks in the routing table. But the one thing that can be of concern is, can I ping it directly? The answer is no. Because why? When you ping it directly, say for example you want to ping this guy, and he will use them. So OSPF will say, okay, you're not sourcing it from routes that are non-transit. So meaning that my ping will fail. 100.02. Actually it passed. Although that is iOS XE. But I have seen cases where you do not see that condition. But if you see it, add your source. But if I type in show IP OSPF database, I can still see the trend, the transit interfaces. Notice that they are removed from the database, Why? Because we're telling OSPF, don't take them down. They are your peers, but don't kill my CPU. Don't kill my CPU with those transit in my database. I only want to focus on the routes that are non-transit to save resources. Any questions regarding prefix suppression? Okay, no question. Okay, so the question here, what is the difference between PRC and ISPF? PRC is a partial routing calculation feature that focuses on routes that are flapping and preventing OSPF from resetting the entire database. Then the ISPF, that's an algorithm that looks at the entire topology. It doesn't look at partial routes or like what PLC will do. Does that answer your question, or Liami? PRC, no, it's not a new technology. It is part of the OSPF PRC 2328. That that was when it was introduced. Although the very first RFC of OSPF, which was OSPF version 1, that PRC was not introduced. It was introduced with OSPF version 2 and going onwards. So it's not a new technology. It's just that it's not really spoken of. So people are not really talking about it because it's a feature that you hardly change in your network. So, but these things, believe it or not, they do exist. Reda, hope that answers your question. Okay, so if there are no further questions, now let's go to the not so stubby. So with the not so stubby, oof, this is my worst nightmare as well, because I've seen the stuff that it caused. So now, okay, so now why would you need not so stubby? Not so stubby is also part of the stub routing, but the only difference is it will be stub routing with redistribution privileges. I'm gonna sound a bit dirty, so please forgive me. it's like you have friends with benefits. So you guys know what I'm talking about. But yeah, so picture picture not so stubby that way. So if I go back to the topology, I've got um, the backhaul. So the backhaul has a DMVPN network. So I'm running EIGRP here. So now I'm running OSPF stub routing, which will prevent this router from becoming an ASBR. Because with the normal stub routing, OSPF says, but wait, you are a dead end. You are not supposed to become an autonomous system boundary router. So if you want to change that, we need to now elevate your not so stubby. But now you will find that, okay, so where do I start? Where do I start? Do I go into the console, send a technician out, log into the console, change the mode? You can plan it, and this is how you can do it. But I'm not sure how is it in your networks. So say, for example, you are in head office and you want to log into this guy. You want to change area 2 into a not so stubby area. So with the not so stubby area, so you first want to log into the dead end first, because if you don't do that, you change it from here, you will lose access to this guy. So keep that in mind. So if you change him, yes, you lose access, but if you now change this side, he will come back. So it's all about order of operation. So if I go back to my terminal, I just want to open another one. Hope it will allow me to open another one. Ah, there we go. Uh, okay. I don't have another one. Okay, that's fine. So I'll go to telnet 10.10.103.255.5 cast 1, and noticing that I've got the DMVPN networks that are coming from the kiosk, and I'm using the wireless service provider. So the wireless service provider is a triple PoE server, and it's LTE, etc. So I won't go deep into that because that's going to eat up time. If there's time, I'll show you how it's configured. So I'll type in show IP route EIGRP. So now the intention is I want to inject these routes into OSPF. So let's try to do that without without elevating anything. And I'll put in redistribute EIGRP 100. So it took the command, it didn't complain. Show IP OSPF database self-originate. And would you look at that? He says, no, don't bend the rules. You told me that I must not be an ASBR. What's wrong with you? Why are you breaking the rules? So it's like the router is screaming at you, saying that, hey, follow the rules, mister. Follow the rules. So I will go to the router and I'll apply OSPF 100. And before I do that, there's one more thing that I didn't mention. So in here, I made sure that I don't have any limitations. So what that means is I'll apply no area 2 stub. I will lose access immediately. And let's say, for example, you do it and you don't have a change, and 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 the kiosk networks are down. They'll say, hey, who authorized the change? Who authorized it? So I will then go back. Come on. Why am I not? It's waiting for this guy to fail. Okay, it's fine. I'll bend the rules. I'll log in here because it's waiting for that guy to fail. So the neighborship has gone down. So then I'll go to telnet 10.103.10. Just check what is the directly connected interface. Okay, that'll be the one, 10.103.11.2. I have access. There we go. See, so I confirmed access. So now I want to go into this guy and I want to set him as a not so stubby. But before you do that, you need to negate the existing condition. So it'll be no area 2 stub, and it'll be area 2 not so stubby. I'll press enter. So now this here doesn't have any conditions. So then if I log into the other neighbor and I go to router OSPF 100 area 2 not so stubby. Okay, so the neighborship should come up. There we go. So then the neighborship is up. So then if I go back to the management console, you're still thinking. Okay. Okay, so I will log into him that way. So then I'll type in show IP OSPF. That will be database self-originate. So now look at these routes. So these routes that are coming from EIGRP, now they are tagged as LSA type 7. So with LSA type 7, LSA type 7 is not allowed to leave an area. But as soon as it lands in the ABR will use the P bit or the propagate bit to translate the LSA type 7 to type 5. So picture that as NAT. You cannot advertise a private IP over the internet, but you need to NAT it. So picture the P bit in that fashion. So so if I go into the regional office and I type in show IP route OSPF, so because I am in the same area as that router, I will see these routes. But now, what if I want to see those routes from the CE? But if I do that, I'll type in show IP OSPF database and it's a say external. So now, what will tell OSPF to translate an LSA type 5 or type 7 to type 5? Well, this will be this value here. So you want to see the type 7 to type 5 translation. What this means is the prefixes that came from that not so stubby area will also propagate in the LSA type 5 table. So type in show IP OSPF database. So I will see, go down. I will see the LSA type 7 routes, but the very same routes, I will see them in LSA type 5. What this will do, this will allow David to see the routes from his PE and also transport them back to Cape Town. David, do you mind confirming that for us, please?
No, I don't. So I should log into, is it Cape Town?
Johannesburg. So these routes are coming from the regional office.
Going to the DC.
Yeah, so they need to be advertised to the DC.
Just before before you, let me see. That is 255. Okay, let me share my screen then.
Okay, let me stop sharing. There we go. So while David is sharing, are there any questions regarding the not so stubby? No questions? Okay.
I think these terminologies they are easy to demonstrate, but when it comes to an interview and then you are being asked to start explaining these,
There we go. So those routes that came from the kiosk network, notice that they are marked as LSE type 5 under OE2. So they are not marked. Notice that they're not marked as N2 or N1, meaning that an LSA type 7 is not allowed to leave an area. It's allowed to be translated. So what is the benefit of using the not so stubby? Well, if I redistribute from a route that has routes that from a routes, let's say EIGRP to OSPF, the benefit is that the area border router does not have to generate LSA type 4, which is the ASBR summary, because the ABR is the one that is translating those LSA type 7 to type 5s. So that is the benefit. But what's the downfall? The downfall is if you have if you have another area which is a not so stubby, and you have type 7 routes being translated to type 5, those routes will not be allowed to enter another not so stubby area. So be worthy of that. So that's where your planning comes in, where to apply stuff, where not to apply stuff. So what I can say is stub routing, only configure it in your dead end where OSPF domain ends. So if I can take over, David, thanks for confirming.
Sure.
Okay, so can you see my screen?
Yep. Yep.
Okay, so now the question is in this regional office network, where does the OSPF domain end, or where does it start? Excluding Cape Town, it starts from this PE, going to the CEs, extended to the regional office switches, and then it ends here. So meaning that this area here is eligible to be a not so stubby or stub area or totally stub, depending on what you want to do. So if let's say you happen to have a third party link coming in and you want to now bring those routes in, then you can now elevate though you can elevate those your stub routing to be not so stubby to honor that condition. So now the other thing is, okay, so now when it's not so stubby, what about what is this now? What am I doing? Sorry, showing you stuff that you shouldn't see. Okay, so what about the default route? So if I go to 11.2, I type in show IP route OSPF. So notice that now I configured not so stubby, and then now the kiosk people are saying, "Hey, you made a change last night. After the change, my internet access failed. No, it's your fault." you know, in those war rooms, they'll fight. No, 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 no. I didn't change anything. No, go ask Martin and David. They were busy with the change. So now in here, in here, notice that with the not so stubby, it will not inject the default route by default unless you configure the totally not so stubby area. Then that way it will inject the default route by default, and that's where the default control comes in. You can say, for example, if we decide to add, let's say, another site here or another router, and it happens that we add it as area 3, we can say, you know what, area 3 doesn't need a default route. They only need specific routes, meaning maybe they have their own breakout and we don't want to influence their breakout. So we can just give them specific routes and not a default route. That's the benefit of not so stubby. You can control who needs to get the default route and who does not need the default route. And you can also control the metric, the metric and the metric type. So say, for example, I want to advertise metric type 1 this path and metric type 2 this path. So let's make that happen. So I will go to the regional office 100. I'll say area 2, not so stubby, contextual help. So the keyword is this guy, default information originate. So this will now pull the default route that's coming from wherever it's coming from, inject it into the not so stubby area. So I'll put in the default information originate contextual help. So I can say, you know what? Always translate it, keep it in not so stubby, or configure a totally not so stubby, or say, you know what, you are not allowed to redistribute. So you can tell a not so stubby area, although it has redistribution capabilities, you can say, wait, no, you are still not allowed to redistribute. So you can be that ruthless. I would say don't create unnecessary enemies. Come on. If you configure not so stubby, give the guys the privilege to redistribute. So then I will add the metric type 1 contextual help. I can also control the metric, but I don't want to do anything here. I just want to inject the default route. So now let's confirm if the not so stubby is getting the default route. So we show IP OSPF database self originate. If I go, and there we go. Where are you? There it is. So here's the default route. So he is injected into area 2. So let's see. Are you done playing your games now? Okay. 255.5. So if I type in show IP route OSPF, so notice that now I am receiving a default route with OE1, and I influenced it to come in as metric type 1. So if I go to regional office number 2, I can say, you know what? Feel free to load balance the default route. So I will go out. Nope. Where am I? Okay. I'll do it from here. So will be what? Actually, not that. Hey, Martin, what's wrong with you? Okay, can you please explain how metric differs to? Okay, I'll come back to you, Olayami. So I'll go to show run pipe section router OSPF. So in here, what I want to manipulate is this. So I want to remove this and this because the idea is we wanted to load balance, but that will create asymmetrical routing. So be aware of that. So apply it with special caution unless it's really necessary. So the no area 2 default cost and no area 2 stub. So it'll be area 2. Not so stubby, default route, give it the same metric type 1 and type 2 and press enter. Okay. And if I log in to 5 again, and I type in show IP route OSPF. Is this neighborship not up? Let's see. Why is he not load balancing? Is it because it's coming in with a higher metric? Let's see. Okay. He's coming in with a higher metric because he's influenced by the CE. So I forgot that these middle links here, I'm using them as HSRP. And then this guy, he's influencing the metric. Okay, that's fine. That's not a problem. So if I type in show IP OSPF database, so the question is, am I receiving that default route? And yes, I am. And as you can see, they do not have a tag. What does that mean? It means that if I am controlling the default route control in the not so stubby, and I have another OSPF domain here, what that means is the OSPF tag that came from here, I will strip that OSPF tag off and mark it as 0. If I mark it as 0, that simply means that I am managing that default route. So always note that. All right. Okay. So now it's that thing of, okay, so Martin, you have now enabled the not so stubby, but now we are still receiving these small bits and pieces routes. Can you please suppress them? Okay, no problem. So then I will then configure the totally not so stubby without impacting the redistributed roots that came in. So I'll go to 1. And I'll go to router OSPF 100, and that will be area 2, not so stubby, default dot metric type 1, and the keyword no summary. This will tell OSPF that you are at totally not so stubby. You're not allowed to receive the specific roots under LSA type 3. So what does this mean? It means that now you will only receive a default route, and you will still have the benefit of redistributing routes and advertising them back to the area 0. So I'll do the same in the secondary switch. So there'll be router OSPF, and there'll be area 2, not so stubby, default route, metric type 1 still. And this time I'll add not so stubby. So then I will go out back to the CE. So I still have access from head office. So I'll type in show IP route OSPF. But notice that this time I am receiving a default route only. But now the question is, under which LSA will this default route be under? Can anyone answer that? Anyone?
Maybe you can repeat the question so that we get it clear.
Oh, okay. So now that I'm receiving a default route, so based on this output, under which LSA will this default route fall under?
Will it be type 7?
I don't know.
Guys, we can even guess. It's not cast on, it's not about being. We know the different types of LSA. You can say type 1, type 2, type 3 until we get it right.
Come on, guys, give it a try. So Martin says LSA type 7, and anyone else?
Hello, please, what was the question again?
Sorry, Mansur, you mind repeating yourself there?
Yeah, I didn't get the question. I'm just trying to.
Oh, okay, no problem. So the question is, based on the output that you see in the screen, which LSA type will manage this default route? Okay, Oloyami says LSA type 7. Mansur?
Is this node an ABR or an ASBR or?
This will be an IR, meaning it's an internal router. It doesn't have a leg to it doesn't have another leg to area 0. It only has one area.
Okay, so Martin, from that output, the code there is inter area, so I think that would be type 3.
Type 3. Okay. All right. Anyone else?
Where is this route on the topology? Maybe you can show us on the topology. This customer
No.
one
No, no,
RGO.
no, 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 no. No, no, no.
It's okay.
That will be cheating.
It's okay. You can tell us the correct answer then. We have type 7, type 5, type 3 as the
Ooh, type
respondents.
5. Okay. So so I have LSE type 3, type 5, and type 7. And anyone else? Come on, guys. It's not, I'm sure you guys are working with OSPF in your networks.
I'll because this one is just no other leg. I'll go for type 5, area 5, type 5. Sorry.
Type 5. Okay. Type 5. All right. Okay, so moment of truth. Now let's confirm which LSA is it. So I'll type in show IP OSPF database. And the answer is the default route will propagate in LSA type 3, but will not propagate in LSA type 7. So David wins.
Hallelujah.
So
type
what?
7, type 3.
So type 3, yes, because it's under the summary network.
Summary net. Yeah, summary net.
So the question is why is it why is it put under LSA type 3? Well, anything that is marked as totally stub or totally not so stubby, the default route will always fall under LSA type 3. But it will not strip off the default route coming from the LSC type 7. It will still keep it in the routing table, but it will not remove it will not propagate it in the routing table. It will only keep it in the database. So if I go to show IP OSPF events LSA and we go all the way down, jeez, there's a lot of logs here. You know what? Let me do it this way. Let's man. Come on. There's a lot of logs. Okay. Let's see. Let's see if it will allow me to see the default route. There we go. So as you can see here, the ABR, the two ABR routers, and to confirm that they are ABRs, if I type in show IP OSPF border routers, it will say, okay, I have these two guys as ABR slash ASBR. So if I look at this LSA table, I will see that the ABR generated the default route under LSA type 3. All right. Before I ask questions, let me address the question of Olayami. Can you please explain again how metric type 1 differs with type 2? Okay, not a problem. Let me explain it this way. All right, confirming that you guys can see my paint. Okay, not a problem. So now, say for example, you have let's say 3 routers here. And let's say this router is connected to ISP1, this router is connected to ISP2. And say, for example, the cost is 1 all over, assuming that it is gigabit interfaces. So metric type 1 says, I will allow I will expose the real cost to the destination. So meaning that, let's say this guy has a LAN segment here. And when this router learns the default route, he will tell him the real cost to the destination of where he wants to go. That's metric type 1. So if we go back to the basis of OSPF, OSPF uses cost as a method to determine the best path. So the metric type 1 propagating the 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 cost to the destination, it does influence OSPF to say, okay, I'll mark you as the best path because you're using what I want. But that doesn't mean that it will not use metric type 2. No. So let's say here will be metric type 1, this will be metric type 2. So if I'm injecting routes, let's say this is BGP. If I'm injecting routes from BGP into OSPF and I tag them as metric type 2, what I'm insinuating to OSPF that the routes that are coming in, I do not want to expose the real cost to you. I'll just advertise them to you. So this guy will say, buddy, I'm receiving routes coming from LSA type, metric type 1. I will just keep you as my redundant route, and I will not use you in my RIB table. But if you are both metric type 2s, I will both make use of you guys, meaning that I will control the routing with a metric. Does that answer your question, Oyalami or Olayami? Oyalami, maybe you want to phrase your question differently.
In this topology, Martin,
Okay.
where is the ASBR?
So these two guys are ASBRs.
Okay, so the external cost because when we talk of this cost, there is always a mention of the external cost and the internal cost. So I think if you could use that, maybe it
Yes.
would be much clearer.
Exactly. Yes. External and internal cost. If you can use that to explain.
Okay, no problem. So when you redistribute routes that are coming in from BGP with metric type 1, the route will be marked as OE1, and the default seed metric will be 1 in this case, right? And then on here it will be OE2. So with the OE2, the default seed metric will always be 20. So what will happen here is that the metric type 1, because it reveals the real cost. So what do I mean? If I want to go to the internet and I land here, if I go through him and I go through him, the default cost will be 2, right? But if I come in, because now the metric type 1 influences a cost incrementation, that will now influence the cost to be 3 dynamically, right? Although here you are also seeing the exact same cost, which is a cost of 2, but the seed metric here is 20 because it's not revealing the real cost to the destination. So meaning that when he comes in, instead of 20, he will become a cost of 22. So he will not use this path. Does that answer your question?
Well, a bit. So type one, we had external and internal cost, right?
Mhm.
Why type two we only consider is the internal cost when advertising the route.
So yes, so hence I'm saying that with the metric type 2, you can manually influence the cost. You can say, instead of using this guy, I will use maybe cost of 1, but OSPF will still not choose metric type 2. He will still go for metric type 1. So I want to show you an example of why I'm saying this. So if I go to the data center, it'll be 255.5, yes. And I go to show run pipe section router OSPF. So notice here that I have the default information originate type 1. And if I go to the redundant router, show run pipe section router OSPF. And when he is configured this way, he will be marked as metric type 2 by default. So what that mean? What does that mean? So if I go to the regional office, so I want you to note this this IP quickly. So I would like you to note this IP. Sorry, not that IP. Let me go to the primary. Sorry, my apologies. So I want you to note a specific IP when we run the trace. So if I go to show IP interface, so I'll be 1 and then David will be 0. So please note this IP here. So I will go out. I will go to the regional office, and that'll be 3. So I'll type in show IP root OSPF. So here will be type 2. Why? Because that root, when it came in, David is so because of these two PEs are communicating via BGP, the routes that are coming from head office, they need to be injected into BGP so that the routes can be received in this PE to inject them into the OSPF process. So the reason why I'm seeing metric type 2 is because David applied a default information originate without influencing the metric type. That's why it was metric type 2. So then let me switch off the domain lookup. And let's see, although the firewall will block it, but we want to note the path. Let's say I want to trace that. Notice that it's taking the metric type 1 path. Remember this IP here?
Yes, that was the IP.
Yes. So what this does, the metric type 1 will influence David's PE to see this path as a best path and this path not as a best path. But with the default information originate that I apply here, basically I'm handing off the default route to David, and I'm telling him which path he must use to come back to me, right? So and then David will be his responsibility to inject those into BGP for him. But how he injects that default route into the OSPF process with the regional office, that has nothing to do with how I injected the default route here, because in between there is BGP. So BGP will still follow this path when I trace, but when it lands here, it will now look at, okay, so which one is the best path on OSPF? That's why it chose this path. Does that answer your question? Okay, cool. Are there any further questions regarding the not so stubby and the default route control? No questions?
Yes, I believe we can proceed to complete the remaining concepts in the next
Okay.
20 minutes, maybe.
Okay, cool. So now let's now go to the the OSPF fast reroute or the OSPF loop-free alternative. So why would you need? Oh yes, Uyalami, you wanted to ask something?
No, sorry.
Oh,
I just
okay,
missed.
okay, no problem. So the question is, why would you use OSPF loop-free alternative? So going back to the topology, if we go back to the EIGRP, to the Cisco speaking people, um, with EIGRP, remember that you have your successor and your feasible successor. That's if the route is eligible, or if the route passed the condition of the feasibility condition. Now, on the other hand, OSPF doesn't have that feature enabled by default. You need to enable it. It's not enabled by default. So I'm going to demonstrate it here. But what's the benefit of fast reroute? Fast reroute, if let's say the loopback 10.100.0.4 is known via this path. If he goes down, SPF now needs to recalculate the best path again. So fast reroute says I will add in a repair path. So the terms are similar, but the wording is different. So with EIGRP, the best route will be the successor, and the backup route will be the feasible successor. So the backup path in OSPF will be the repair path. So let me go into the switch here. 10.10.255.1. So if I type in show IP route OSPF, I will see all of these guys here. But now the question is, if this guy goes down, he will need to now recalculate, although he has multiple peers. Just because he has multiple peers, that doesn't mean that he'll just fail over immediately. No, that's not how it works. He must now recalculate that path. So if I type in show IP CEF or Cisco Express forwarding, and I type in 10.100.0.4, notice that he says my next hop is this, and I have not injected the backup path. And that's where the loop-free alternative comes in. So now with the loop-free alternative, so if I go to the configuration, how to enable it, it will be fast reroute, contextual help. So we want to look at per prefix. It will be per prefix contextual help. And we don't want to change the tie breakers or tie LFA or remote LFA. We want to enable it. So it'll be enable. And then contextual help, we only have area 0. So we want to look at the prefix priority. So the prefix priority, there's high and low. High means it will focus on loopbacks. Low means it will focus on loopbacks and the transit. But if we look at our routing table, we suppressed our transit routes. So meaning that we don't want to waste resources into OSPF to tell it to focus on routes that are not even in the RIP table. So in this case, I will go with high because we have loopbacks. And I will repeat the command. And this time, I will say keep all paths. What this does, it says, Mr. OSPF, if it happens that you have other alternative paths that were not tagged, please look for them as well. So I'll enable him. And if I type in show IP OSP IP OSPF, not actually Ceph, I meant to say. So notice that now we can see a repair path. So meaning that we just saved the SPF algorithm or the Dijkstra algorithm from having to recalculate the other path. But let me make this clear. This is not meant for fast convergence. This is meant for resources, saving resources and preventing the router from having to use a lot of resources to keep on calculating. So now you need to enable this. So if you after fast convergence, BFD is your best friend. If you are looking for saving resources and telling OSPF to have the backup path in the bag, then loop-free alternative is your best friend. So I'm going to do that in all switches. So that'll be router OSPF 100, and that'll be fast reroute per prefix enable prefix priority. That'll be high. Fast reroute keep all routes. And to confirm that it is up, you want to type in the command show IP OSPF, and that will be fast reroute prefix summary. To show that it is prioritized, you want to look at these values here. So the reason why on the low it says 0, it's because we didn't tell it to look at the transit. We only told it to look at the loopbacks. But now if let's say I want to look for a transit route, and I type in show IP Ceph 10.100.1.0, he'll say, wait, you told me not to look at you told me not to look at the transit path or the transit routes. You only told me to look at the loopbacks. So if we check 4 again, then 4 has the repair path. So I'm going to do the same in the rest of the switches quickly. And this can be quite beneficial, especially in networks that are running software-defined access. If you happen to run OSPF or even ISIS, it can be beneficial for the MPLS as well, because the fast reroute can also focus on the labels. So the fast reroute, if you tell OSPF to sniff the MPLS labeling process, then the fast reroute will also look at the redundant label and the redundant path as well. But that's if you want to do that. But that's the benefit. So it'll be fast reroute per prefix enable prefix priority, that'll be high, and fast reroute keep all links. And I'll go do it on the last guy. OSPF, oops, sorry. OSPF fast reroute per prefix enable prefix priority high, fast reroute keep all paths. Okay, there we go. Okay, so that is that about the fast reroute. So just to confirm, Ceph 10.100.0.1, he has a repair path, he has a repair path, he has a repair path. So meaning that if the link goes down, then SPF says, okay, I don't need to recalculate. I already know what's the best path. I'll just use that path. Any questions regarding the loop-free alternative?
Okay, I have a question. So, if you say it doesn't, it's just to conserve resources, but it's not recalculating. So definitely it should be faster, I believe.
Well,
If it doesn't have to calculate. And
well,
secondly, before
mm,
you answer, sorry. Secondly, is about the VPN FRR. Does it
mm.
mean it's the same scenario? It doesn't. It's just to conserve the resources by having a repair VPN part or a secondary part. Yeah.
Are you, are you referring when you say VPN? Are you referring for the L3 MPLS VPN?
Yes. Exactly.
So so the FRR within the MPLS L3, that so OSPF will sniff that if you tell OSPF to have a leg inside of the data plane of the MPLS forwarding, or the control plane, if I can actually the control plane, sorry, because the data plane will be the forwarding, and then the control plane will be making the decisions of which path must it take, or which links must you look at. But if you don't tell OSPF to do that, it won't necessarily have a leg in the FRR, in the MPLS forwarding process. So to answer your question, when it comes to fast, it's not fast reconvergence. It means I don't have to recalculate, because now if I have to recalculate, I now have to talk to everyone, because remember OSPF has a map in the topology, and I have to now talk to everyone. Hey guys, what is your cost? What is your cost? What is your cost? So we are preventing OSPF from doing that. So, but when it comes to the link failing, OSPF still needs to abide to the hello and the dead. That won't go away. So to prevent the hello and the dead being slow, you want to look at BFD. But to tell OSPF, hey, don't recalculate every time when a link fails, because you have LFA enabled. Does that answer your question, sir?
Okay. Thank you. How is it different from TI LFA?
TILFA. That one I have not touched on that one, to be quite honest. That'll be on the service provider side. David, I don't know if you want to answer that question.
Um, I think the first time that I heard about TI-LFA was when I was dealing with segment routing. Um, um, I don't think there's much difference per se, but I would be lying to you if I give you a difference in this particular session. Maybe it's something that I can research, and probably one of these days when we're doing the segment routing session, we can discuss about it. So off the top of my mind, I can't give you the clear difference between those ones.
Okay, thanks, David. Are there any other questions? Okay, we can proceed. So we have done the LFA. Now we can tackle the route filtering. So the route filtering, that's where the distribute list comes in. So there are two methods. Actually, there are three. You can export routes using a prefix list. You can export routes using an access list. You can also export routes using the one-way redistribution. So meaning that if I come here and I say routes that are coming from BGP, I do not want to inject those specific routes. I'll just tell David, you know what, David, you don't need these specific routes. I'll just give you a default route. As long as I have the default route in the routing table, and I apply the default information originate in the routing table, and then David will then honor it. So before I proceed, do you guys have any questions regarding route filtering? Were there any scenarios that you wanted to address or that you wanted to ask questions about regarding route filtering in OSPF? Okay, not a problem. Okay, so I will go to the MPLS. I won't go to the regional office because it's running OSPF everywhere. So it'll be 10.10.255.5. And say, for example, I'm telling David, you know what, David, I want to give you these two prefix. I only want to send you the two prefixes that I summarized and the default route. So I will start with the prefix list. So it'll be IP prefix list, and there'll be OSPF filter out sequence 1, and I'll say permit 10.10.0.0/18 exact match, and I will also add the 255.0/24. Then I'll go to OSPF and I'll put in distribute list. Distribute list. I'll call out the prefix list, which is OSPF filter out. And contextual help, where do I want to go? I want to advertise to David, so the direction will be out. So be worthy of the direction. You don't want to end up dropping the network and kicking yourself out. So be mindful when it comes to the direction. So if it's in, it means routes that are coming in from another OSPF segment. But if it's out, you want to advertise it to your peers. Okay, so if I type in show IP prefix list detail, and notice that it says, wait, those routes, I am not learning them. You are summarizing them. So I cannot touch those. But what can we do? We can say, you know what? Can bend the rules. Go to no IP prefix list OSPF filter out sequence 1 and permit 10.10.00/18. But when you do this, do note that you can easily drop the network. So do it with special caution. So I'm doing it because I'm accessing this router via BGP /24. So then what I want to do, I would rather want to say, you know what, I want to go up to a /31. And the second one, I would like to go up to a /32, meaning that all the routes that are under the last octet, focus on them. So if I type in show IP prefix list detail, notice that now I am getting matches. Did I put in all of it? Oh, I forgot the second one. Sorry, my apologies. Filter out sequence 1 permit 10.10.00/18 LE31. There we go. So if I type in show IP OSPF database self originate, so those routes, although I am filtering them out, David will not receive will receive those summaries still, but he will still receive you will still receive routes that are not part of the summary subnet mask. So if I go back to the OSPF, so this will be the command here with the distribute list. That's if you want to use a prefix list. But let's say you want to use an access list. So I'll go to the access list. I will name it as OSPF filter out. And this time I'll put in permit 10.10.00. If it's a /18, it'll be 192. So it'll be 00.63.255. And I'll say 10.10.255.000.255. So what am I insinuating here? This won't be an exact route. So this here will say, okay, so I will search for subnets that will fit under this phrase here. So if I go back and I go to 10.10.00/18, so the first IP will be 10.10.0.1. The broadcast, so the broadcast will be a number less of the next network. So the next network will be 1664. So that means the broadcast will be 63.255. And then the last IP will be 10.10.63.254. So now which networks can be involved here will be 10.10.00 up to 10.10.64.0. That is what the summary is saying, or that is what the access list is saying. And then with regards to the 10.10.255.0/24, with this wildcard mask, basically I'm saying the zero, don't worry, sorry, the zero says match, 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 and then the 255 says I don't care what that value is. So that is the terminology of an access list. So we will go, so I'll go to the OSPF process. But before I do that, I want to go to the OSPF filter, and I have these two statements. I'll go to router OSPF 100, distribute list, and this time I want to add the access list. So now the question is, how do you add an access list? So if let's say you have an access list there that is numbered, whether it's an extended or a standard, it will fall under these. But if the access list is named, you want to put in the actual access list name. And in our case, we named it as OSPF filter out, and the direction will be out. But now he says, wait, but you need to negate the prefix list first. So it'll be no distribute list, prefix list, OSPF filter out, direction out. Repeat the command. Here we go. So if I type in show IP access list, OSPF filter out, I will see matches as expected. All right. So then that is the first. And then what if I want to configure a one-way redistribution? So basically I'm saying, you know what, I do not want to give you the BGP routes. I just want to give you a default route, and that's all I want to give. So I will go to the router OSPF. I will negate the distribute list. I will also negate these as well. And if I type in show run pipe section router OSPF, You should learn the directly connected interfaces, including the default route. So I'll do the same in the redundant. So what I did is, in the summary, sorry, in the negation, this will no longer be applicable because the routes that I want to summarize are not injected in the OSPF table anymore. So I will go to the secondary. So I'll type in show run pipe section router OSPF. So in here, I'm not summarizing anything. I'm just giving a default route with also redistribute connected for the directly connected interfaces. So if I go to the regional office router, which will be .3, now type in show IP route OSPF. Notice that I am receiving a default route, and also I'm receiving the, actually, where is this guy coming from? Okay, so I'll negate him. So, and I'm also receiving the directly connected interfaces. So this will be a null. I'll get rid of this. So that is how you can run the one-way redistribution. So now what I did was I logged into this router using the loopback. What does that mean? It means if I go back to head office and I want to access the loopback, the expectation is that the loopback needs to know how to come back to my IP on this box here. So now, because this router doesn't have specific routes, he will now rely on the default route. So now if I go back and I type in show users, let's see where I'm coming from. So I'll type in show IP route 10.10.2.11. So let's see. Okay. Sorry, I need to negate this. Just give me a second. Give me a second. Let me get rid of that. So that will be. So I'll just negate this one. Might have found directly connected somewhere. Okay. So then I will go back. Now type in show IP route 10.10.2.11. Notice that it says, wait, I don't have that route in the routing table, but how can I still access that loopback? Okay, so now let's now ask this router, which route are you using to get there? So I'll type in show IP Ceph 10.10.2.11. And Ceph says, well, Martin, I'm using the default route to get there. And in return, the BGP is redistributing the specific routes back into, sorry, the BGP is redistributing the OSPF routes into BGP, and that's the one-way redistribution condition, which can be beneficial when it comes to reducing your routing table size, and also if let's say there are sites that don't need that large routing table. But do that with special caution, because the default route can be quite sensitive. You lose the default route, everyone goes down. So be cautious of where the default route is coming from. So rather do that knowing very well that the default route is coming from a reliable source. Okay, any questions? No questions? Okay, so that, guys, will be the end of the session. So now I will take in questions if they are there.
Thanks, Martin. Guys, let's ask questions before we end the session. If you have any question, you can unmute and ask, or if you have any comment, you can also unmute.
Martin, I don't have a question, but I want to ask Sefo if what he was looking for in this session, he was able to see the PE to CE pairing where we're using OSPF, if it's clear to him and any other person who might be interested in that.
Yeah, no,
Yes.
I'm crystal clear. And thanks to
Great.
Martin for this presentation.
Cool. Okay, so I know you guys. This was a very beefy session, and if I can tell you, we we actually touched on 20% of OSPF. We didn't actually touch on everything. We didn't touch on the multi-address family OSPF. We did not touch on sham links. We didn't touch on the we didn't touch on virtual links. So there's a lot. And then there's a lot involved in OSPF. So OSPF, it can easily be a weak discussion if you ask me. But yes, yes, Martin.
Yes, I was just supporting your point of course, we haven't touched a lot of things, but yeah, we are on track.
Okay. So are there questions, comments? What else will be required? Or what else do you want to see from the topology that might not be part of the session?
I just got a question there. In terms of labs, which tool would you recommend as the best tool in terms of either uh, learning BGP and OSPF, making use of either Huawei or Cisco?
Without a single doubt, Tsepo, I
Mhm,
will recommend EVNG without a single doubt.
mhm,
And reason behind this, although Peanut Lab, the features are for free, no
mhm,
doubt about that. But
mhm,
it's not really a maintained tool.
mhm,
It's not a maintained tool. And sometimes, yeah, you will experience issues where it crashes, and it will be a pain. Believe me, this thing made me sleep late at night when it crashed. Believe me, this lab, when you see it being all fancy doom and gloom, hey,
yeah,
there are tears and fuck in the background. But I
yeah,
wouldn't. If you want to learn the protocols without any sort of disruption, even G.
mhm,
And I'll always say this. Yeah?
yeah,
Learning is not cheap.
yeah,
Learning is not
correct.
cheap. If you want the best out there,
Mhm,
you need to go deeper into your pocket, or else you will not learn anything. That's the reality.
yeah, true
So
that, true that. And make time as well.
yes, you need time. And the other advice is don't lab alone.
Mhm,
When you lab alone, sometimes can be quite frustrating, and you're not sure if you're doing the right thing.
mhm, mhm,
um, then one last thing that I'll say is la- la- labbing labbing is for you to understand the concept, but labbing will not always address what's really happening out there. That's the
yeah,
difference.
yeah,
So like if you check this PE here, you see a fancy purple line here, but
mhm,
you'll find that in this purple line, there's two service providers involved. Yes, two L2 service providers, and
Yeah.
then one says, you know what, I will accept this MTU size, and then going forward, it's not me. I'm not fragmenting your packets. Go check your other provider.
Yeah.
So there's a lot involved in the real world, but labbing will just teach you what really happens out there. But I would say if you lab in topologies like this, it'll give you foundational knowledge of the real world. I would
Yeah.
say 20-30%. Then the rest it will come from your work experience. That's what I would say.
Thank you, Martin. And just also to add, we really appreciate you guys' as a unity and all the sessions that you guys are doing for us, because people out there are very selfish. And I just hope that everyone who's attending the sessions, they are taking them seriously, because it's very rare whereby you find people like yourselves making time for guys that are still on the ground level of learning networks and being patient with everyone. I really love that, guys. And
Yeah, thank you, Tsepo. Sharing is caring. It took me a lot of years for me to be here, but I started somewhere, and I know the feeling of having to learn things yourself.
yeah, yeah,
Asking people, although there were people out there that did help me in my journey.
uh-huh.
So in my journey, I'm actually preparing for my second attempt of the CCIE lab exam, the enterprise.
Yeah, nice one, nice one.
So so and the thing is, thanks. The thing is, when you teach someone, and I've learned this a couple of years ago, is that when you read a book
Uh-huh.
and you lab,
Yeah,
when you lab, there are two things that are happening.
uh-huh.
Actually, a couple. When you lab, it will increase your typing speed. But if just because you're fast, it doesn't mean that you know what you're doing.
Exactly.
I'll just call you a typist. I'll just call you a typist. But are you accurate in what you're doing?
Yeah,
So it is. So you can be an average typer. I can be a super fast typer, but you will be more accurate than me because you know what's required when it comes to certain topics or certain stuff that's required to bring a specific service.
yeah.
See what I mean?
Someone said if you can't explain it in simple terms, then you don't understand it.
Yes, yes. So I believe that when you teach people, you're also challenging yourself.
Uh-huh.
Do you really understand it?
Yeah,
Because I can say, you know what? Like for example, I'm gonna give you an example with Oyala or Olayami. I really appreciate your questions. Don't get me wrong. And Olayami's questions are valid. And what they are teaching me is that not everyone will look at OSPF in your perspective. So some will understand it in their perspective because we are running a multi-vendor networks here, and I'm
yeah,
using Cisco. Huawei can have a different approach.
yeah.
Juniper can have a different approach. So that's why you teach. Um, People share their experiences with you.
Uh-huh. Uh-huh. Yeah, thanks.
Thanks, Sebo, for that. And yeah, if you also have a topic, you're welcome to come in and share the knowledge with the rest of the team. I can
Uh,
confirm.
I,
Yes,
I can
yes.
say I can say that I can say that I'm just lack of a better word. I work around different areas of IT, and I'm a master of none. So being someone who works across different things, at times to me it seems like a curse. So it's better for people that are dedicated to one special thing and then they are specializing in that area.
Not really. I wouldn't agree to that statement.
Being, being a jack of all trades at times it limits one.
Yes, but at the end of the day, there is always that one area. As much as you're handling different aspects, there is always that one area that you feel this is my area. I believe we are all in that way. We may be in networking, but you see, also networking is wide. So there are domains in which we can say we've mastered. There are others that we haven't not. So
Uh,
I will still invite you to come and give a session despite your explanation, but it's okay. We get it. And again,
yeah,
we
no, the time will come and then I'll take that with both hands.
definitely thank you.
All right, thank you.
And we appreciate you guys taking your time also to attend this session. I believe we all have a lot to do over the weekend, especially after tough weeks during the work days. You have a lot to handle, so creating time to attend to this session and even to respond to questions that are being asked in the group, that is also being helpful to many others who are in the group and they are seeking help in different domains. So we appreciate the contribution of all of us.
But unfortunately for some of us, if we are struggling, then we are all alone. You know, I'm working, I think, with plus minus a team of 20.
Yes.
Three of us are black people, and the others are the other race. I'm not a racist, but as Africans, I think it's time now we stick together and then share the knowledge and the skill.
I agree.
Yeah, because it's very sad. Whenever people approach you and then you are always there for them, but when you are stuck, you are all alone. Then you spend plus minus 24 to 72 hours to come up with a solution.
You're not alone.
It's
That's
not.
why we are here. Okay, anyone else with a comment?
Hi everyone, thank
Yes,
you.
Stephen.
Hello, hi everyone.
Yes, we can hear you.
Stephen, I think you're too close to your mic.
Oh yeah, can you hear me now?
Yes, we
Go
can.
on.
Yes. Thank you so much for the session. It was so much um, detailed and instructive and productive. As for me, I echo with Shape of Power. Um, Previously, I was in SP industry, but later on, I moved to enterprise networking. But this session has made me go back to service provider industry. The knowledge is there, but it has been revived. So at the end of the day, in the group we have different specializations, but at the end of the day, as Martin said, uh, as professionals, we all have that very strong specialization that brings out our strength. But at the end of the day, we are all round. So this is very important for the team. Thank you so much.
Thank you, Stephen. You're welcome. Anyone else? Anyone else before we close? David, Motiva, do you have anything else to add?
Maybe I just in response to what Saifo said. I hope I'm getting his name correctly. You know, yeah, we have given you some sessions, but believe you me that when I say that we are also learning actually when we do these sessions. So in a way, you're also making us better. And like Martin has said, sharing is caring. So the more I share, the more I also get to learn, because for us to come here and you know, for example, Martin has given you like 3 hours of presentation. Believe you me, there's a lot that is happening in the background. You know, you have about a week to prepare for this session and ensure that you've covered all the basics, just to, you know, give you the content that can help you out there. So that preparation also, in a way, we also learning, and we get to be better than we were yesterday. Yeah. So we let's keep in touch, and say for you, we definitely have something we can learn from you. So just sit and think of what you can share with the group, and we can organize a session, and we can give you the audience to take us through, because everyone here, I believe, has something to offer. And Martin, if I could say, I think it's high time we had a lady also come and give us something. We don't have to. This session don't have to be male dominated. I remember. I remember Eve's session was highly attended. So maybe we could also encourage our sisters. You know, one can pick up the mantle and run with it. Anyway, thanks guys for allocating time, and thanks Martin for being the leader of this community, and thanks Martin from South Africa for the good presentation, and for also bringing me in again. So hope guys do not get tired of our voices, but it was a very good session and interactive.
Okay, no, thank you guys. I will definitely do of something that I can share knowledge with the rest of the members, and then I'll let you know in time.
Thank you.
Thank you.
Okay, I believe this should be the end of this session. And again, I appreciate all of you for your time and the active participation. We will be uploading the recording. Hopefully by tomorrow it will be available, so that you can review the recording, and if you have any questions, follow-up questions, you can always share on the WhatsApp group, and we will be able to attend to them. Thank you so much, and again, keep inviting your friends, your colleagues. Let them join us and be part of this community. We keep it growing. It is a community to empower us to help each other and give back to the community. So let's spread the word. Let's invite our friends. You can be here, but you know someone who needs to attend to this session, but you haven't told them. I believe you should be able to invite those who you feel need to be part of this community, so that they can also learn, they can also share, and we grow the community. So thank you so much, guys, and I hope you will be having a good evening.
Yeah, thanks, Martin. See you all, and I hope your teams are winning in the World Cup. So all the best.